In this section, we're going to continue and look at data modeling as well as database characteristics. Now let's start off by looking at some definitions. First of all, we need to understand the concept of a data model. Now, a data model is a diagram of data entities and their relationship with one another. So if you think back to our previous discussion, we said that an entity is an object, a person, a thing that we want to gather information on. So how do these things relate to each other? So typically, if we look at this example here, we've got various entities, and those entities have some sort of relationship between them. Some other words that you might find is that people talk about enterprise data modeling. Now, enterprise data modeling is an extension of an ordinary data model, but it's applied on the level of the entire enterprise. So it could typically show you all the information available within your whole organization. So it's going to be a little more complicated. And the idea behind it is that it shows you how information is shared amongst various processes, departments, individuals, databases, and applications. Now, for the rest of the discussion, we're going to focus on entity relationship diagrams, or ER diagrams. And the ER diagram is a data model representation where we're going to use specific symbols and lines in order to show the relationship between entities. So typically, if we look at this particular one here, this square or the triangle, the rectangle represents an entity, a salesperson, and then that salesperson interacts with another entity, which is a customer. Now, when we talk about databases, we typically refer to relational models. Now, a relational model is what we saw on the previous page and also what we're going to see here. So we've got various entities. In this case, we've got 3 entities, 3 tables that we're going to create and record information for. And then these would be linked to each other as 2-dimensional relationships. So 2-dimensional table relationships. So all entities are typically linked to each other. Now, if you want to work with relational model databases, some of the applications you're going to use are usually for large organizations: Oracle, IBM DB2, Microsoft SQL Server, Microsoft Access, MySQL, and Sybase. Now, there would be some others that you can also encounter. If we continue and look at the next definition, a domain indicates a range of allowable values for each of your data attributes. Now, if we talk about data attributes, these represent our fields. What's the information we want to record? For example, if we look at the following 2 cases, date of birth as well as ID number. For a date of birth to be recorded in our system, we know the following. We can't set it to be in the future because that person hasn't been born yet. It needs to contain various numbers in the format of day, month, year. And then, just for interest's sake, the oldest recorded person was 122 years of age. So typically, you wouldn't find a date of birth older than 120 years from 2017. If we look at ID numbers, we also know that ID numbers should be numbers. It should be 13 characters long. If you go and count the digits of your ID number, you would see it's 13 characters. It typically includes your date of birth. The first six numbers includes your date of birth. And the next combination of numbers typically includes your gender, it might include your race, and it might include some validation information. So all of these indicates what we are allowed to do with the attributes and the range of values that we can accept for those attributes. Now, when we start to talk about manipulating data, there's 4 concepts that we need to work with. So once your data, your records, has been recorded in your database, there's 4 categories of manipulation that we can actually go and apply. First one, selecting, whereby we're going to eliminate certain rows according to specific criteria. Then we've got projecting, where we eliminate columns in a table. We've got joining, where we combine two or more tables. And we've got linking, where we combine two or more tables by looking at common data attributes. And then again having a new table with unique data. So let's look at each one of these four manipulating techniques by applying real-world information. So at the top we see that we've got some basic information. So we've got 4 records: surname, name, date of birth and gender. So these are our attributes. We've got our 4 records. In this case, the primary key would be a unique number for each one of those people, and we don't have any evidence of a foreign key, so we're not going to concern ourselves with that. So if we look at selecting, for selecting we said it's eliminating rows according to certain criteria. So for this data set I can go and say, give me a list of all the female participants, meaning that it's going to give me a list but only show records number 2, 3 and 4 because they are the female participants. Alternatively, I can say, okay, give me a list of all the participants that's older than 21 years of age. We've got the date of birth information, and if we look at that, we would find that the top 3 people would be older than 21 years of age. Number 3 would be 21. Number 2 would be 27 and number 1 would be 37. So eliminating rows based on certain criteria. If we look at the next one, projecting, we said it's eliminating columns in a table. So now for the same set of data I can go and say, show me a list of all the participants but only show the name and surname. So it's only going to show that and it's going to exclude the other 2 attributes or columns. Another example, display a list of all the attributes but only display date of birth and gender. Again, it's going to exclude the names and the surnames. Coming to joining. Now in this case we're working with multiple tables, so I've added an extra data set. So we've got, let's say for argument's sake, information or data for 2016 and then data for 2017. So joining is where we're combining 2 or more tables. So I can say, give me a list of all participants for 2016 and 17. So what the system will do is it's going to take each of these tables and combine them together. So you're going to end up with 8 records. If we look at the next one, linking, combine 2 or more tables through common data attributes to form a new table, only with unique data attributes or values. So if you look at our data, you will see that Maya, record number 4 in this case, as well as record number 3 in this case, is actually the same person. So for example, we can say, give me a list of all the participants who's repeating a particular course. And then the answer would be Maya. Now, when we design traditional or relational databases, we need to talk about what is known as a database schema. Now up to this stage we've seen examples of Erd diagrams, our entities with their relationships. We've seen examples where we've got the raw physical information, our actual data, similar to what we had here. But with a database schema we're going to take that and we're going to represent all that information in a more textual based manner. So this is nice if you want to get a list of all the fields or tables in your database as well as all the attributes together with the primary keys and possible foreign keys that there might be. So for example, if we look at the following, we've got a project entity, a department and a manager entity. So these are represented by the words at front. So project, department, manager. We're going to start off with an open curly bracket and we're going to end it with a closing curly bracket. Now if we look at our actual data, if we look at the project table, we see that we've got a project ID in the first column. That is unique and that is a primary key. We've got an attribute description and we've got an attribute department number. However, department number are linked to the department table. So what we see is we've got a primary key, project ID. Now a primary key, we always represent it with a hash symbol at the end of it. Then we've got an attribute description and we've got a foreign key department number. Because what did we say? What is a foreign key? It is a primary key from another table that is used as a foreign key in this particular table. So all foreign keys are indicated with by underlining it. Let's look at the next one. Department, name of the entity, open curly bracket, department, we've got a department number. So that's our primary key, so we indicate department number hash. We've got a department name and we've got a manager social security number. So manager social security number is actually a foreign key because it's a primary key in yet another table. So we know foreign keys, you go and you underline that. Let's look at manager. The primary key for manager is social security number. So manager social security number hash. Then we've got last name, first name, hire date, and we've got department number. Now yet again we know department number is actually a foreign key because it's used as a primary key in another table. So this represents a database schema. Now, in order for you to develop a database, there's a few steps or stages that you need to go through. And we're going to look at each one of these in more detail. The first one is you need to go and identify all the entities. Secondly, you need to identify the relationship between entities. And lastly, you need to identify attributes and then finally resolving all the relationships. So for each one of these, we're going to go in a little more detail. So let's start off with the first one, identifying all the entities. Now, again, we said identities is everything that you want to store information of. So for example, it could be people. In the example presented on screen, we've got managers, users, we might have tasks and processes, etc. As we go through some examples, you would perhaps understand it a little better in order to see how we typically identify entities. The second step is to go and identify all the relationships. Now, the relationships between entities are governed by enterprise or business rules. So if we look at this example here, a manager can serve various departments. So manager can serve, that indicates many, so many departments. And then a department will be served by one manager. Let's look at the next one. A department can perform many projects, but one project is performed by one department. So let's look at these. So a manager can supervise many departments and a department is supervised by one manager. So that represents an enterprise or a business rule. Now for interest's sake, you see that in this case we've got two sentences. And it comes down to you need to read it from this entity going into this entity, then also backwards from the department entity going back to the manager entity. Because you need to explain what's happening there and you also need to explain what's happening there. So that explanation is typically your enterprise rule. Again, as we continue and we do more examples, it's going to make a little more sense. Now, after identifying the relationships, there's some other things that we need to pick up. So first of all, we need to look at the number of entities involved in a relationship. Now, it's always two entities because we're linking one entity to another entity and we have a single relationship between those, so it's a binary relationship. And that is typically referred to as the degree between relationships. The next term that we find is cardinality. Now, cardinality can be described as the type of relationship between entities. For example, from one entity to another, we might find a one-to-one relationship. Alternatively, we can find a one-to-many relationship. And finally, we might find a many-to-many relationship. So again, if we go back to our example, this is a one-to-many relationship for each of these, one-to-many relationship. As we go on, I'm going to show you some additional types of relationships as well. The last terminology that you need to know about is optionality. Now, optionality is where we've got a binary relationship where it might be optional or required for a particular relationship. So optionality would amount to, if we look at the example that we had before, let me just quickly find that, the previous section that we discussed. Optionality would be the indication of that circle there as well as the line there. And then cardinality would be the type of relationship, which would be to one to many. So one to many, and then it's required there, but it's optional there. So don't worry if it doesn't make sense yet. At a later stage, as we're doing the examples, it will become clearer. Now let's start to look at these concepts applied in another example. Now what we know is we've got entities and we've got relationships between these entities. This is indicated by a degree, which indicates it's binary relationships because it's a relationship from one entity to another. We know the cardinality and we also know the optionality. Now these are recorded in what is known as the Erd diagram, or entity relationship diagram, which is what you see right in front of you here. So if I ask you, what do we see? It's important that you start to look at the way in which the information is represented. So what we know is whenever something is represented in a box or a rectangle, it is an entity. And we know an entity is an object, a person or a place that we want to record information for. A relationship is indicated by a line. So all entities, or entities might have a relationship to other entities. And then you would see that sometimes you get this weird symbol here, which is also known as the crow's foot notation method. Now, when we talk about the cardinality, we said there's different types. There's one-to-one, one-to-many, many-to-many. So if we look at these, we've got one. If you just look at the line there, there's a single line going up to 3, so it's one-to-many. Between order and project, we see it's many-to-many. And then if we look at supply and product, we see that it's one-to-many as well. If we look at the optionality, we see that if it's represented by a small line, it's required, so it should have a link or it should have a record associated with it. Or it might be optional, meaning that it doesn't require that. So let's try to make sense of this. So typically people can give you something like this and they would ask you to identify the entities as well as identify the cardinality and optionality. So in this case, if I asked you how many entities do we have, the answer is 4 entities. What are they? Customer, order, product, supplier. If we look at the cardinality between customer and order, it's a one-to-many cardinality. If I ask you to give me the business or the enterprise rules, we can translate it to the following. Now remember I said you need to have 2 sentences. First of all, going from customer to order to explain that, and then going back from order to customer to explain what we see there. So in this case, a customer might, because it's optional, place many orders. So customer might place many orders. An order should be, it's required, placed by one customer. So again, an order should be placed by one customer. So those two sentences represent our enterprise or business rule. Let's look at the following one. An order is composed, or order should be composed of multiple products. A product might be found in many orders. So what it means is, if you want to place an order, there should be many products within that order, but a product might not be required in all of the orders. Let's look at the last one. A product should be supplied by one supplier. However, a supplier should supply many products. Okay, hope it makes sense, but as we're doing more examples, it will become easier and easier. Now let's look at the third phase that we need to look at. We need to identify all the entities that we wanted to store information about. So we identified the 4 entities. And now we should go and record all the attributes for each one of those entities. So for example, if we look at customer, we will probably have a customer ID, customer name, surname, and contact details. For supplier, supplier ID, supplier name, contact details, etc. Then the last phase that we need to look at, resolving all of our relationships. And this comes down where we need to look at the type of relationship and to determine whether we're going to have a foreign key or not. Now remember, we said whenever we represent a primary key, we put a hash in front of it. Alternatively, if we want to represent a foreign key, we underline it. Now there's actually a rule that we need to have in order to identify this, and we're going to speak about that shortly. So again, just to recap, we've got 2 tables, 2 entities, customer and order. And if we look at the order table, we see that an order is placed by a particular customer, which is our foreign key. Now, later on I'm going to talk about the rule. At this stage I'm going to leave it. But what it comes down to is that we need to look at the one-to-many relationship. And it's going to indicate that the to-one primary key will become a foreign key into many. If it doesn't make sense, don't stress at this stage. Now let's look at the next 2 slides just to get an understanding of some of our enterprise rules and different types of relationships. For example, if we look at the first one, we've got 2 entities, employee and passport. If we write down the enterprise or business rule, again, from this one to that one to get that, and then backwards from passport to employee in order to determine that. So let's interpret the first one. Each employee have one and only one passport, and then each passport must belong to only one employee. We look at the next one. An employee might have a car. A car should belong to one employee, meaning that your employees, all of them doesn't need to have a car, but again on the other side, you don't want cars in your company and you're not going to assign it to any employees. Let's look at the third one. An employee might have a laptop. A laptop might be assigned to an employee. So as we go through it, hopefully it becomes a little easier. These we've seen. A customer might place many orders. An order should be placed by one customer. A student might have one elective, and an elective might have multiple students. A student should have many tutors, and a tutor should have many students. So, very importantly, look at the business rules, because in some cases companies would give you a business rule and they would expect you to come back and to draw something like this by just looking at that business rule. And we're going to do an example of that at the end of the class. Now let's talk about two concepts called data cleansing, or also referred to as data scrubbing. Now, data cleansing is the process of detecting and then correcting or deleting incomplete, incorrect, inaccurate or irrelevant records within our database. Now the reason for this is we want to make sure that all our content is accurate, complete, economical, flexible, reliable, relevant, simple. All of the characteristics of valuable information, because that allows us ultimately to make better decisions. So the goal is to improve the quality of our data. So typically what we find is that data cleansing, and this happens after information has been placed in our database. So you would have people coming, looking at your data and then removing irrelevant data or wrong data. Alternatively, we have a concept known as data validation. Now, data validation is when we accept our input data, as soon as we realize there's a possibility for error, we automatically go and correct that. For example, if we need to type in a date of birth and we find that it's set for the future, the system can automatically go and prevent us from doing that, indicating that the person hasn't been born yet. So that's data validation. It happens in real time. Now, the cost of performing data cleansing because it's done afterwards, it requires you that you go and hire people. They need to work through multiple records and tables. It's very time consuming and ultimately it's very costly. Now, let's look at the last example here. On many systems, if we think in terms of South Africa, as soon as you enter street addresses, these kind of things, typically you need to enter a city as well as a postal code. Now the system can automatically go and once you've selected a city, enter the postal code on your behalf. Okay, so that would be data validation, ensuring that that data is correct at the time of entering it. So let's stop here, and then with the next section we continue to talk about database management systems.